All right, so we can solve this nodal problem. The way that you would know it usually is when it's asking for a voltage at a node, or it might say perform nodal analysis. And our steps in nodal, the first step that we always want to do is label the nodes, which this one is pretty much already labeled for us, A, B, and C. Note there is a node inside of here, and then all of this down here would be the ground. So we can label it, I usually label it G, and then I'll label this D for now, just so that we can remember to consider it whenever we're doing our nodal analysis. So I label the nodes, and I guess you could also say label the nodes and voltages. Or is that my second step? I forget. Either way, the voltages. Do I know the voltage at A? Yes, I do. It's this right here. VA equals 5 angle 30. And this is positive, so it's positive 5 angle 30. If that had been a negative, it'd be negative 5 angle 30. But it's a positive 5 angle 30. That's my known voltage at A. I don't know the voltage at D, and I don't know the voltage at C. But let's just say that all of those are unknown right now. We do know that is VB is what we're solving for. So VB is what we're solving for. I have two other unknown voltages, but I'll tell you right now, what you don't want to do is try to do a system of 3 equations. So let's see if there's other ways that we can ignore the fact, not ignore, but find other ways to deal with these unknown voltages. This first one I can do by putting this into a box right here. Right? Remember how we said we could always put Z's into a box? And so now this Z value inside of that box is 100 plus J 50. Right here it says 50 ohms. It's an inductor, so it gets a positive J. The R is 100, so it's 100. So that is my Z inside the box. So now whenever I'm going to do these Ohm's law, I'm going to be able to go from VB all the way to ground without needing to worry about D. The other thing that I can see is that this right here is a current source. Right there is D, or sorry, is a current source, so I can ignore C. So by being able to, I don't need to worry about the unknown voltage at C because I know the current going through that leg. So label the nodes, the voltages, and then that was, I guess, step 2. 3 is I'm going to draw the currents. And that's kind of what I started to do when I said I have a current source here. So I'll draw those in red. I'm just going to draw them all going out. Is everyone okay with that? Or would everyone like them in? Everyone's okay with out? Okay, we're going to go out. There's 1, there's 2, and there's 3. 1, 2, and 3. I'm going to be picky and label them all with I's. I1, I2, and I3. And then we always said, so we drew the currents, and there's the currents at the unknown voltage. So whenever I say unknown voltage, I mean the unknown node, which is B in this case. We said we could ignore C since it has a current going through it. We can ignore D since we can put the impedance in a box. So now the fourth step is our favorite law, Ohm's law. And so at I1 is going from VB to VA over this 75 ohms, but it's a capacitor, so it's negative J 75. I2 is going from VB down to ground. Ground is 0, so it's VB minus 0 over both of these impedances, 100 plus J 50. I3 is going from B through C down to ground, but I know it's current. So I don't need to worry about the Ohm's law. I already know that it is 2 angle 40. Note that my direction of I3 right here matched the direction of the current source. If it was the opposite, then just put a negative on it. You know what I think I just realized is I said this was the 4th step. That's the 5th step. The 4th step is KCL, which is all of these together. I drew the currents, but because I drew them all out, it's I1 plus I2 plus I3. And honestly, you can swap those steps. If you had found Ohm's law for I1, I2, and I3 before you did the KCL, that would also be fine. It would give you the same answer. It's just a matter of plugging these I's into this formula. So 0 equals VB minus VA over negative 75J plus I2 VB over 100 plus 50J, and then the last one plus 2 angle 40. And I just plug them all in, and you can use a solver, you can use algebra, but hint, hint, that's your final answer. Any questions on that?